So this is lecture 2.5, equations of lines and linear models. For many of you who had intermediate algebra at Cocoa campus or any campus, this will be review for you. For those that have not, maybe dual enrolled students, all of this may be new. So for those for whom it is review, I'm just going to suggest you kind of look over the notes or look over the e-text, this section in the chapter. Pay attention to the things that are new to you and go ahead and get through the homework, because the upcoming sections will be new to you. For the rest of you, here it goes. So what I'm going to do right here is we have many different equations of the line, and the general equation that you've already been introduced to is ax plus by is equal to c. And the only restriction, of course, x and y, this is an equation in the variables x and y. A, b, and c are real numbers, and the only restriction is that both a and b can't be 0. So if a is 0, b can't be 0. If b is 0, a can't be 0. And every single graph of a straight line can be expressed by an equation of this form, including horizontal lines, vertical lines, and lines with any positive or negative slope. So I'm giving you another type of an equation for a line. This is called the point-slope form, and as the name suggests, if you're given a point and you know the slope, then you can use that to get an equation of the line. But I want to derive that formula for you. That's one of the reasons I want to do that. It's because this is college algebra, and you should be at the level of sophistication that the derivation of a formula should be of some interest to you, and you should be able to follow it. You don't have to memorize it. So this is just some generic point right here I've drawn. So this is a generic line in yellow, and this is just a generic point, and it lies on the line, and it has some x value and y value for its coordinates. Now suppose that there is another point that lies on the line, and I actually know its coordinate values. Now I'm going to not write a number here like 7 and minus 3, or I guess minus 3 and 2 by the picture or something like that. I'm just going to call it generically x1 and y1. Now when we put subscripts there, I'm just telling you right now what these mean. It means x1 is a known value and y1 is a known value. But up here, the x and the y, it just stands for some generic point on the line. So we have the slope, m, is equal to delta y over delta x. Let me make my line a little bit thicker. Well, that's going to be equal in this case to y minus y1 over x minus x1. So I have the formula, to repeat it here, m is equal to y minus y1 over x minus x1. And you should be getting to realize that we don't like rational expressions. I don't want this to be a fraction. Now notice I put parentheses around the x minus x1 in the denominator. You don't have to do that, but what I'm going to do is I'm going to literally multiply the top m times, I'm going to multiply both sides by x minus x1. So when I multiply the left-hand side on the top, I get m times x minus x1, and when I multiply the right-hand side, the x minus x1 factors out, I get y minus y1. And that indeed is the point-slope equation, form of the equation of a line, except we normally write y minus y1 is equal to m times x minus x1. And what is this it's an equation of the line with slope m. So the slope has to be defined, so this won't work for vertical lines, that passes through the point x1, y1. And this is a really, really, really handy equation. And that's exactly what I give up here. Y minus y1 is equal to m times x minus x1. And it's the equation of the line with slope m. So again, it has to have an existing slope. If the slope is 0, that is an existing slope. The slope can be 0. In that case, you have a horizontal line. And it passes through the single point x1 and y1. So let's just go ahead and use this information to solve some problems. So here we want to write an equation of the line. It says an equation, so you get to choose which equation you want, of the line through the point minus 4, 1 having slope minus 3. So let's do that. We're going to use the point slope formula that I just derived. It's right here. I'll kind of scoot it over here, maybe make it a little bit more level. Keep it up there in the corner. So our slope here given is minus 3, and our x1 comma y1 value is equal to minus 4 and 1. So literally at this point it's just plug and chug. Using this formula, y and x are our variables, they're free. So y minus, notice the minus is inherent in the formula. That means if a value of x1 or y1 has a negative attached to it, it's got to bring it along. It can't use the existing one that's already there. So y minus y1 is equal to m, which is minus 3, times x minus, and here is the example. My x1 value is minus 4. That minus 4 has to come along with it. It can't use the minus already there. I keep saying this because it's the number one error that I see in algebra. So the final equation is y minus 1 is equal to minus 3. All we have to do is simplify what's in parentheses here, and minus a minus is a plus. Minus 3 times x plus 4. And you're done. I mean, you could have done it the other way. You could have used the fact that minus 3 is the slope, and that's the same thing as minus 3.1, minus 3 over 1, and you could use slope addition, or sorry, point addition, with the adder point taken from the slope, and gotten another point, but you don't really need the other point, but you already have the m, and maybe you could have found out there's other ways to do it, but we don't even want to go down that road because we have a completely good method of doing it here. Using the point slope formula given 2 points. So here we go. So we want to write an equation of the line through the points minus 3, 2, and 2 minus 4. So I've got a point. What I don't have is the slope, so let's find the slope. So I have point 1. You get to choose which one is your x2 and your y2. And I'm just going to be lazy and choose my first one is x1 and my second one is y2. This is x2, y2. And I swear I don't even delta y over delta x is the difference in the y values. So I'm going to say it's y2 minus y1 over x2 minus x1. And it does not matter. If your y2 is the first in the top, then your x2 has to be the first in the bottom. If your y1 was the first in the top, then y2 would have to be the first in the bottom. If you have no idea why I said that or what that means, just ignore it. It has to do with we get to choose which point to label. At any rate, this is minus 4 minus 2 over 2 minus, the minus 3 has to bring its negative along with us. So minus 4 minus 2 is minus 6. And 2 minus a minus 3 is 5. So I have minus 6/5 is my slope. So now I can choose either of these 2 points. It does not matter. So we'll just leave this one. We'll just choose this one. I've already labeled as x1, y1. But you could have just as easily chosen this other point. And we're going to use the formula y minus y1 is equal to m times x minus x1. So don't obsess about which one of these points is y1 or x1. You get to choose. You could have easily just relabeled this one over here as x1, y1, and this one x2 and y2, and it's still going to work. Again, that whole spiel about the validity of mathematics does not depend upon our choice, but this I will tell you. If you do have a choice and you have enough wits about you to think things through, choose the one that makes the math easier. So y, I did not do it this time. We'll see. Y minus y1 is 2. And minus 6/5 is m. That's where I get my m. That's the first thing I calculated. Y, so I could use this very formula. X minus x1 minus 3. So I get the following equation. Y minus 2 is equal to minus 6/5 x plus 3. And you're done. You don't have to solve for y. Now, if you want to solve for y, you can. And when you do, you have f of x is equal to mx plus b for some b. But the m is not going to change. Your slope value will never change. But the point I want to say is this is a perfectly good equation of a line. And if you're not asked to write it in function form, because remember f of x is equal to y, then you can write it this way. And it's particularly good if you're given points and you're asked to write the equation of the line by looking at the points. Okay, so let's look at this one. So we're asked to write an equation of the line given by the graph below. So clearly what we want to do is we want to find 2 points. Now you might actually be able to look at this and say, well, the line is going off to the left as we move. So just in case you don't know, slope is negative, which is less than 0, if you're walking from left to right and you're going downhill. At the slightest grade, you're still going downhill. So this is going to have negative slope. Slope is positive if you're walking from, again, from minus infinity to infinity, this direction, and you're going uphill, even at the smallest grade. So you could actually look and say, well, the rise is 1 and the run is minus 3. So I'm suggesting the picture is, I'm going to put a point right here and a point right here. And I'm going to start here and I'm going to say, oh, well, I'm going up a positive 1. So my rise is equal to 1. But then I have to go to the left, 1, 2, 3, so minus 3. So we're going to suggest minus 1/3 is going to be our slope. But let's do it by finding the coordinates of the point. So this is clearly the y-intercept. So the x-coordinate is 0, and the y-coordinate is minus 1. And this point right here is clearly the x-intercept. So the y-coordinate is 0, and the x-coordinate is minus 3. So let's choose. I'll say this is x1, y1, x2, y2. So our slope m is equal to y2, which is minus 1 minus 0, over 0 minus 3. See what will happen if you don't bring the minus 3 with you? So minus 1 minus 0 is minus 1, and 0 minus a minus 3 is plus 3. You would get a wrong slope. You would get a positive slope rather than a negative slope. So I have my slope. So you can do this visually or by literally just identifying the 2 points. Sometimes you will have to identify the 2 points. In this case, the visual was really easy to see, but many times you won't be able to. You'll have to figure out what the point values are and go from there. So now we're going to use the equation y minus y1 is equal to m times x minus x1. So we have to have 1 point. So we'll use this as my point right here. I could have chosen minus 3, 0, but I'm going to choose 0 minus 1. So y minus y1 is minus 1 is equal to minus 1/3, that's the value of m that I discovered, times x minus x1, which is 0. So let's simplify that. Y minus a minus 1 is y plus 1 is equal to minus 1/3 x. This is a nice little equation here because it's easy to solve for y and get it into another form. And but that's all you have to do for that one. Let's see what our next problem is. Okay. So we have the slope-intercept form. Again, this works only for equations that have an actual slope. Remember, 0 is a bona fide slope. There's nothing wrong with having a slope 0. So if a line has a slope of 0, that is a defined slope. 0 is a real number. The only lines that do not have a slope are vertical lines, and their slope is simply undefined. So let m and b be real numbers, then the equation y is equal to mx plus b is an equation of a line where the slope is m and the y-intercept is the point 0b. So just some things to talk about here. The y-intercept is a point. We're in 2 dimensions now. I think in high school they don't teach it this way. They teach you the easy way. And they say the y-intercept is b. No, that's not right. B is the y value in the point whose x value is always 0. So I will say that many different times. If you write on the test that the y-intercept is just one number rather than a point, then I will absolutely deduce points, because you have to remember the context of math right now for chapter 2 is the coordinate axis, the Cartesian plane. We're in 2 dimensions. So every answer that lies on the graph has to have 2 pieces of information. That's the reason they're points, they're ordered pairs. So let's actually use this. I'm going to again open up a new, I don't want to save it. Let me just use my hand. New canvas. There we go. Nope, you don't need to see that. As fascinating as it might be to me. Did I accidentally close it? Okay, I've got to start it. Hold on, people. Sorry about this. I guess now that this is up, I should tell you I made a few changes to it. So they're just minimal. but you might want to reload it. If you loaded up the notes for before today, which is September 20th, you might want to reload it. Nothing major, it's more or less grammatical. I rewrote to say what I wanted to say, and more or less they're not substances changes in formulas or anything like that, but choices of A versus and, V versus A, those types of things. So let m and b be real numbers, then the equation y is equal to mx plus b. So let me give you an example of one. We actually just did one. Y is equal to 3x minus 7. So let's compare that to y is equal to mx plus b. My slope m is 3. And here you go, the red, not 3x. 3x is a variable term, and I don't know its value unless I know the value of x. We actually do know the value of the slope, and it's 3, not 3x. And our intercept, the y-intercept, is always of the form 0 plus some number b, because when a graph crosses the y-axis, the x value is 0, and in this case, the b is literally minus 7. So the intercept is 0 minus 7, not minus 7, but 0 minus 7, because the y-intercept is a point. Not a real number, not a one-dimensional real number, but a two-dimensional point. So let's see what kind of things we are asked to do. So write an equation of the line given above by finding the slope and y-intercept using the slope-intercept form. So I think we just actually did that. So by the above, I mean on the previous page, which I just erased, but I will remind us that we found that the slope m, whoops, not that color, the slope m, a little bit too hard to see, is equal to minus 1/3, and we had a point 3 minus 2. So we had, using the the point slope formula, y minus y1 is equal to m times x minus x1, and that gives us y plus 2 is equal to minus 1/3 times x minus 3. So this is point slope form. That's what I'm given. But what I want is y is equal to mx plus b. So this is my given, and this is what I want. I want an equation in this form. So clearly I have to solve for y. So the first thing I'm going to do is I'm going to ignore the left-hand side, and I'm going to use distribution over here. So that's going to be minus 1/3 x. And minus 1/3 times minus 3 is plus 1. And now all I have to do is to solve for y is to move the 2 to the other side, and it becomes negative. And I have y is equal to minus 1/3 x minus 1. And if you will recall, that's exactly what we had the last time. And if you recall some more, we didn't choose the point 3 minus 2, we chose another point. But we still got the same answer. So again, I reiterate, in mathematics, if you're given a choice, then the validity of the results do not depend upon that choice. So when you're sitting there and saying, which point do I choose? Remember, it doesn't matter, because it will get the same answer in the end. So equations of vertical and horizontal lines. So the equation of a vertical line, that's a line that goes straight up and down, that's what it means to be vertical, has the equation x is equal to a for some number a. So let's draw a really quick, fast Cartesian plane, and we'll draw a vertical line. Close enough, right? I don't want to load up GeoGebra. So whatever this point is right here, it's where the line crosses the x-axis. So we know it has some value x and the y value is 0. Let's just say x is 5 and the y value is 0. The equation of this line is x equals to 5. That means if we look, no matter what, this point up here, it's going to be 5, and I don't know what its y value is. The y is free to vary. And down here, we also have x equal to 5, and y is another value. So y can vary. Y can be anything, but x is constant. So this is what we would do. Just write the equation of the line this way. X is equal to 5, and that's vertical lines. And what's the other thing we know about vertical lines? That is, slope does not exist. It's not that the slope is 0, it literally does not exist, because if I were to take 2 points here, let's say this is 5 and 5, and then this one here, 5 and 0, and then I would use delta y as 0 minus 5 over 5 minus 5. The numerator is no problem, but the denominator is 0, and we cannot divide by the 0. Hence, slope is undefined. Now the equation of a horizontal line, I'm going to draw a horizontal line here, and we will hone in on this point right here. The x value is 0 and the y value is some b. Let's just say it's 0 minus 5. And as you'll notice, no matter where I'm at on the line, the y value does not vary. So the equation of a horizontal line is y is equal to b for some constant b. In this particular case, y is equal to minus 5. And of course, this has slope equal to 0. Well, let's show that. Here we have one particular point, 0 minus 5. Let's go up here. We have minus 5 and 5. I'll just pretend that that's a 5 right there. I know it's not because I said that's 5. Okay, then I'll make it 10 if you don't like it. Minus 5 and 10. How's that? So the slope would be 10. Sorry. That's what I mean to write. There we go. So the slope would be minus 5 minus 5 over 10 minus 0, which is equal to 0 over 10, which is equal to 0. So this would be 10 for the x value. The y value is constant. It's always minus 5. And this just kind of encapsulates what I just said. The equation of the horizontal line through the point AB is just focus on the b value. The equation of the vertical line through the point AB is just focus on the a value. X is equal to a, y is equal to b. So make sure you conceptually get that. Don't try to memorize that because you'll think vertical, that's change in y, and you'll want to write y is equal to b. You'll say horizontal, that's changes along the x direction, and you'll say x is equal to a, and you won't get it. But if you draw this picture, then you'll get it every time, and you won't mess it up. So don't memorize, because memorization, one can memorize without understanding. and we want understanding. So here's the theorem. It's called the distinct lines theorem. It's one I made up. It's not in the book. I don't think the book uses the term theorem. I'm very opposed to that. Two lines are distinct if and only if they have different x-intercepts or different y-intercepts. As long as they have different x-intercepts or different y-intercepts, then they're different. Sometimes they will have both. In this particular example, this line has one y-intercept, different y-intercepts, and different x-intercepts. So here's an interesting question for you. Can you come up with an example of two parallel lines that have different x-intercepts, but their y-intercepts don't exist, or they have different y-intercepts, but their x-intercepts don't exist? Just draw pictures and you'll figure it out. And here's another theorem, parallel lines theorem. So here's how it's going to go. In this theorem here, I'm going to use some information that I gave you in the theorem previous. Two distinct lines, well, I know what that means now, are parallel if and only if they have the same slope. So if I have two distinct lines, which means they have at least a different x-intercept or a different y-intercept, perhaps both, then they're parallel if and only if they have the same slope. And that's pretty evident from this picture right here. They have the same slope. And I am going to launch GeoGebra because I'm going to show you the power of mathematics. So I'm going to draw a point right here. I'm going to draw a line through 2 points, one here and one here. So here I'm going to draw another line through a single point. And in my classroom, I would ask people, tell me when to stop when the line that I'm moving right now is parallel to the existing line. And most of you are going to say about right there. But you're using the organ of your eyes. You're using your eyes and eyeballing it. But even if you had instruments, you might be able to measure the distance between 2 points, but that requires that you place them at right angles. And of course your distance measurement is only going to be accurate to a certain amount. You cannot tell. There is no empirical way that you can tell if two lines are really parallel. Because if they're just almost parallel, if we move out far enough, we're going to see they intersect. So where I stopped, they're not parallel. They seem to be parallel right along and through there, but they're not. But just the slightest little bitty difference in their slope. If their slope, one of the slopes is 3, and the other slope is 3.0000000000000000000000001, they're not going to be parallel. I'm going to be able to move out. I'll have to move an awful long direction, and I'll eventually find a place where they intersect. And that's a non-trivial point. Cosmologists right now are trying to understand the geometry of the universe, where the parallel lines are always parallel. And the point is, all our observations right now, to the best of our measurements, say yes, but if they're just slightly off, it may just be if we could extend our observational view to beyond the visible universe, we might find a place where literally space bends back on itself, and no parallel lines exist whatsoever, so space is not flat. And that's interesting in and of itself. So let's get back to here. What were we supposed to do? So let's find equations of parallel and perpendicular lines. So we can't do the perpendicular line yet because I've not given you any information on perpendicular lines, which I will do on the next page. So for this page, that's our objective. So for this page, all we're going to do is find an equation of the line that passes through the point 3,5 that is parallel to the line 2x plus 5y. So what do we need? It's really simple. We have to have two things satisfied. So we have to have, first, what we're going to do is we're going to find the slope. So line 1 is going to be given by the equation 2x plus 5y is equal to 4. So my line 2 is going to be parallel to line 1, but it has to be different. That means one of the intercepts have to be different. And the slopes have to be the same. So the easiest way to find the slope here is just to solve for y and put it in the form y is equal to mx plus b. So that's going to give me 5y is equal to minus 2x plus 4. And now we divide each side through by 5. Minus 2/5 x plus 4/5. So our slope m, which has to be the same for both, is minus 2/5. Now you might be tempted to here just to, out of the blue, just say, oh, well, y minus 2/5, they have the same slope. I'm going to just choose some different. The y-intercept is 4/5, 0, 4/5. Just choose some other value here, like 8. And indeed, in doing so, you've got two distinct parallel lines. But we have another thing we have to satisfy. And my second line has to go through this point. So that little trick won't work. So we're not going to use that trick. We're going to use the point slope form. So I have m is equal to minus 2/5, and I want an equation through the point 3, 5. So we have y minus 5 is equal to minus 2/5 times x minus 3. And we're done. This literally does it. Now, if you want to see what it is in this form here, it says write an equation of the line. This is an equation of the line. Now, if I wanted to write it in the general form, which is 2x plus 5y is equal to 4, is in the form ax plus by is equal to c. If it were to ask you that, you'd have to do some work. This is y minus 5 is equal to minus 2/5 x plus 6/5. Then you'd just simply have to move the x term over here. 2/5 x plus y is equal to 6/5 plus 5. So that's going to give you 2/5 x plus y is equal to 31/5. And then you might as well rationalize the denominators. That's going to give you 2x plus 5y is equal to 31. 2x plus 5y is equal to 31. I was doing that really fast unless I made some error. But the point is, you don't have to do that because you were not asked to do that. I don't know what my math lab might require you to do, but for the homework you have to do what it asks you to do. So here are two perpendicular lines. So two perpendicular lines are perpendicular if when we look at their intersection and look at this angle, the angle is 90 degrees. For those of you who have to go on to Calc 3, you'll be saying goodbye to degrees pretty soon, and you'll be taught an angle measurement called radians, and you'll never want to go back to degrees. So that would be pi halves radians. But completely unrelated, let's look at these two theorems. Perpendicular lines, Theorem 1. Two non-vertical or non-horizontal lines are perpendicular if and only if the product of their slopes is -1. So two non-vertical or non-horizontal lines. So if you have any lines that are slanted and they don't go straight up and down or straight across, they're not horizontal or vertical, then if I take the products of their slope and if I multiply the slope of one times the slope of the other, the product, the answer is going to be -1. This is really easy. Any horizontal line is perpendicular to any vertical line, and any vertical line is perpendicular to any horizontal line. So let's look at this one. Write an equation of the line that passes through the point 3, 5 that is perpendicular to 2x plus 5y is equal to 4. So again, let's convert this into point-slope form. And we may actually have already done it. I can't remember. Is this what we just used? Yes. So we just found from previous work. So from previous work, we found that 2x plus 5y is equal to 4 is equivalent to y is equal to minus 2/5 x plus 4/5. Hence, our slope m1 is equal to minus 2/5. So all I need first is to find my slope m2. m2 is going to be the slope of the perpendicular line. Now, once I find the slope, I'm still going to have to make sure the equation of the line goes to the point 3, 5, but that's really easy. We just use the point-slope form. So if m1 times m2 is equal to minus 1, then these two lines are perpendicular. So m1 is given to minus 2/5. So I have to solve for m2. And when I do so, I multiply both sides by minus 5/2. Why am I doing that? Because minus 5/2, I'm going to give you an easy way to do it, but this is the algebraic way to do it. Minus 5/2 times minus 2/5 is 1. So that gives me 1m2 is equal to minus 1 times minus 5/2 is 5/2. So the slope, here is the trick. And the trick I don't like giving to you. I want you to do it algebraically, but I understand sometimes taking tests there's time pressures. If slope 1, if m1 is equal to, if you're given the slope m1, then minus 1 over m1 is another slope m2 that is perpendicular to m1. So using that here, m1 is equal to minus 2/5. So if I take the negative of its reciprocal, I get 5/2, and that's exactly my desired slope. So I know that the desired slope m2 is equal to 5/2. But we want the line to go through the point 3/5. So that's the additional constraint. So we just use the point-slope form. Y minus y1 is equal to m times x minus x1. And it's just a piece of cake. Y minus 5 is equal to 5/2 x minus 3. And it says write an equation of the line. It doesn't tell what type of equation. So we will just simply stop because this is a perfectly valid equation. It's in point-slope form. Now, clearly, what they're going to do is they want to test you on many different areas, and they say, okay, I want it now in slope, Y-intercept form. So again, you would start with the easiest way. You'd convert it to point-slope form, and then you would solve for y. So take what you've been given, and you would solve for y. Or if they wanted in the general form, ax plus by is equal to c, you just multiply everything out and put the variable terms on one side and the constant on the other. And I would not care if you clear denominators or not. So here's an interesting application, and I think this example 7 is the last example of this particular section. So here's a linear model again, a linear model that has to do with money. They're all over the place. So the average annual tuition and fees for in-state students, so remember the average rate of change, the average annual tuition and fees for in-state students at public four-year colleges are shown in the table for selected years and graphed as ordered pairs. So here's the year 2009, cost is $63.12. 2010, you can see it's increasing. If I were to draw a line through those dots, it wouldn't be perfect. I couldn't draw a straight line through all of them. But you can tell there's probably a straight line that will almost go through all of them, and finding the equation for that straight line is part of statistics. But here, let's read what we're asked to do. Find an equation of a line that models the data. So what we need is to choose 2 points. So let's do that. And here is an important part. The results in this case do depend on your choice. You're always going to get an estimate, but the estimate will vary depending on your choice of points. Now the question is, should you choose the first point and then the last point, and will that better estimate it? Or should you choose the point at the third year up and then choose the point at the these 2 points data right here? Which one? Each different choice will give you a different estimate. So let's put all our pieces together, and in this case it would not matter. Now I don't know what my math lab would do. It would probably say use the point for the year 2009 and use the point for the year 2013 for your estimate. You would have to, because if these points right here don't all lie on the same line, then your choice of point will affect the estimate. If they all actually lied on the same line, then it would not. But in data, seldom do they. We can tell that the trend is more or less linear, but it's not exactly linear by looking at each of the points and being able to draw a straight line through all of them. Why is that? Because measurement data, static, noise, etc., there's errors in measurement. This is a beautiful example of math, though. So it says find an equation of a line that models the data. So what we're going to use is use the equation you find in Part A to estimate the cost of tuition and fees for the year 2015. So notice that my x value is time and my y value is cost in dollars. So let's look at the first. Now what they've done is they've said let 2009 correspond to my 0 x value. And let 2010 be 1, 2011 be 2, etc. You don't have to do that, but it will make it a lot easier when we plug in the year 2015. In 2015, we correspond to a value of x equals 6. So we'll do it that way, because for the second part, you could just plot the point as, first point is 2009, 6312, and the last point would be 2013, 8070. And you're going to find the exact same slope, but then you would have to plug in the value for x is 2015, and that's a larger number, and it's going to be a larger calculation. It'll turn out to be the same, but we're going to do it an easier way. Instead of 2009, we're going to pretend like 2009 is just our start year, and our first point is going to be 06312. And our last point here, x value is 4, is going to be 8070. So let's find the slope between these two lines. So slope m is going to be 8070 minus 6312 over 4 minus 0. Now you all should be able to understand how I got that without me actually separating those 2 points side by side and writing x1 and y1 underneath of them. If you need to do that, then you do it on your own. So 8070 minus 6312 is 380. Well, let's do it. 8070. It looks to me like on my notes, I chose different points. 8070 minus 6312. It's going to be equal to, whoops, I didn't mean to do that. Guess I'll have to use my eraser. $1,758. Did I do it right? 10 minus 8, 6 minus 5, 10, 3. That looks good to me. Divided by 4. So that looks like it has a good chance of being divisible by 4. Let's see if it is. 1758 divided by 4. 16. So we'll do 3, 12, 28, 7. So that's going to be equal to 437. So that's my m value. My m value is equal to 437. Now when I did this before, I chose a different point. I actually chose the first 2 points, the one in 2009 and 2010, and I got a slope of 383. So you can see immediately that I'm going to get something different if I choose different points. So that's my slope. That's the information we need. So what do we want to do? We want a slope through one of these points. So we want to draw a line with a slope through one of these points. So let's use this point right here. That point right here. Why? Because one of the values is 0. So we have y minus y1 is equal to m times x minus x1. So that's y minus 6,312 is equal to m, which is 437, times x minus x1. So literally, that's it. So what we can do right here, if we want, was we have to find the value, the equation to estimate the cost of tuition and fees in the year 2015, which is going to be, if 4 is 2013, then 6 will be 2015. So what I'm going to do here is I'm going to go ahead and multiply that out. I'll do it in 2 steps. Y minus 6312 is equal to 437x. And what was my x1 value? I didn't write it down, but the point I chose has x1 is equal to 0, and that's the reason I chose it. So y is equal to 437x plus 6312. That's the same thing as writing f of x is equal to 437x plus 6312. And they want to find, to estimate the cost in the year 2015. So this is year 2009, 2010, 11, 12, 13, 14, 15. So that would correspond to a value of x equal to 6, which you could also get by subtracting 2009 from 2015. So what I want to do is find f of 6. Well, that's 437 times 6 plus 6,312. Since no calculators are used, we've got to go over here and figure this out. I don't have this figured out before. Like I said, on my notes, I chose a different point to illustrate something. I'm getting 2622. Since I was talking, let's check that really fast. 470. I can't even remember what I'm supposed to be multiplying. 437 times 6, and it's 2622. That's what I got. Plus 6312. So over here, column addition is easy. You know, sometimes I'm bored and I watch PBS for kids, and I watch how they're trying to teach kids how to add. Believe it or not, it's mildly fascinating to me. So f of 6, they're just about at the point of teaching them algebra at a really young age, but they never do. So that the estimated cost is $8,934 in the year 2015. Okay, that is it. Now we have a mathematical reasoning question. Actually, I've already been talking about this. Suppose we chose 2 different points and as a result calculated a different slope. Would the equation of the line that models the data be the same? No, clearly not. Would the prediction of tuition and fees for 2015 be the same? No, clearly it would not. Think about ways one might have a model that best fits the actual data given. I will tell you right now, this is just for you to think about. If you have to take statistics, this question a similar abstract question will come up in the class, unless I'm mistaken what we actually cover in college statistics, but I'm pretty sure it will. Okay, that's it for 2.5.